Today we're going to be speaking about transformations and how different functions change when we add different numbers to them or when we multiply them by different numbers. We're going to start with a fairly simple function with f of x is equal to x squared. You might recognize this function. This is a quadratic function. Now if I give it different values, for example, x, -2. Well, if instead of x, I plug in -2, I'm going to get 4. And if I have -1, I'll be getting +1. For 0, I'll get 0. For 1, I would get 1. And lastly, for 2, I would get 4. Let's plug in these numbers. Okay, we have -2 and 4 up here. -1 and -1, 0 and 0, 1 and 1, and 2 and 4. Yes, we didn't expect this. This is a parabola. Now, let's change this simple function by adding a 1 outside. Alright, so this time my f of x, well, let's change the name so that we won't confuse it with the previous one. Let's call it g of x is equal to x squared plus 1. Let's see how the values change this time around. I'm going to give the same values as before, -2, -1, 0, 1, and 2. For -2, if plugged here, we would get 4 plus 1, 5. For -1, then again, if plugged here, we would get +1 plus 1, 2. If we have 0, we would get 1. If we have 1, we would get 2. And if we have 2, we would get 5 again. Let's see how our graph is changing this time. -2 and 5 is all the way here. -1 and 2 here. 0 and 1. 1 and 2 and 2 and 5. The graph looks pretty much the same as before. The only difference is that now it has shifted 1 unit up. I'm trying to make it a little bit more curved. There we go. So let's see how adding a number outside our function would change our function. The only thing that this one here is doing is to shift the function 1 unit up. So I'm going to write that down. I'm going to write 1 unit up. Now we do expect that if we have a -1 outside, we would shift 1 unit down. The next graph I'm going to work on, let's call it h of x, has a 1 added right next to the x. So for example, x plus 1 to the power of 2. Let's give it values one more time. X and y. For x, let's have -2, -1, 0, 1, and 2. For -2, if plotted here, we know that we have to do the parentheses first. -2 plus 1 gives us -1, and then we would square that. -1 squared is just 1. -1 plus 1 is 0, and 0 squared is still 0. 0 plus 1 is 1, 1 squared is 1. 1 plus 1 is 2, 2 squared is 4. 2 plus 1 is 3, and 3 squared is 9. Let's see, -2 and 1. -1 and 0, 0 and 1, 1 and 4, and 2 and 9. Okay. Now, I can see that I pretty much have a similar graph to the previous ones. Because on the left-hand side, I'm not fully clear how the graph is going to look like, I'm going to give another value on the negative side at -3. -3 plus 1 would be -2. -2 squared is 4. -3 before. Right, I have a better picture on what's happening. There we go. What happened compared to the parent function, or the simplest format of the function, which is started here at 0 and 0, or at the origin? This time we're starting here at -1 and 0. The impact of adding 1 inside the parentheses next to x was for the graph to shift 1 unit to the left side. I'm gonna add that here. 1 unit to left. Okay. Now with the same logic, we do expect that if we add a -1 right next to x, our graph would shift 1 unit to the right side. Now let's consider how our graphs are going to behave if we were to multiply something to them. Okay, we're going to write that over here. This time we're going to call it, how about m of x. Alright, we had x squared plus 1, x plus 1 squared. Now let's have 2x squared. Same values as before, -2, -1, 0, 1, 2. -2, once plugged in instead of x, would first get squared, so -2 squared is 4, and then multiplied by 2, that's 8. Same with -1. -1 squared is 1, multiplied by 2 is 2. 0, once plugged in instead of the x, would give us 0. Even squared or even multiplied by 2 is still 0. 1 squared is 1, multiplied by 2 is 2. And 2 squared is 4, multiplied by 2 is 8. We can see the same values for y, which we do expect because we have seen before our graphs are symmetrical. Excellent, let's plug them in. We have -2 and 8 right here. -1 and 2, 0 and 0, 1 and 2, 2 and 8. Okay, let's take a look at the graph this time. The starting point didn't change. We're still at 0 and 0, or the origin. The only thing that has changed is for the graph, well, it has become a bit narrower. That's the main change here. The reason for that is this number 2 that we have multiplied our function by. Once we multiply a number to our function, it changes how wide or how narrow it is. If we have a number more than 1, like 2, 3, 5, 10, or even a million, we see our graphs getting narrower and narrower. Now we're going to see a few examples where we multiply a fraction to our function, and then after that we're going to consider negative numbers. For that, please go to part 2.